Hello class. I'm going to give you some help today in the form of this screen capture. We will be looking at Arizona Meteorological Network, and they have weather stations across Arizona. Some of these are tied to very agricultural settings, with the exception of Prescott and Payson. As you see here, the green dots are active stations, the red dots are deactivated stations, so you would choose from the green dots. And I get to do a disclaimer. I just tried Prescott and my computer was having some trouble with Prescott. So I'm going to go through this and show you an example for rainwater harvesting and the total amount that you could collect for an area. There's a lot of implications about rainwater harvesting. The efficiencies of doing so, the uses of the water, how much the plants need, and in what time of the year, what season, when the water is most needed, when the plants are most actively growing. And so we'll just do the basics right now, and you can kind of think through those implications, and I could go over some of those when I show you this data. The first thing we want to do is when you go to the link that I've provided that takes you to AZMET, you want to pick a station. I would like for you to do this regardless, just to see this kind of data. However, if you know, or you're keeping track of your own rainfall, or you might even have an active site or a gauge that records the total for the year, that's readily available information. Don't feel compelled to have to use these locations. Some of these locations may mean nothing to you. Some of them may be tied to places you've been or things you're interested in the industry. So since I was having trouble with Prescott, I personally am going to go to Payson. I can identify with Payson, and I want to show you how this data can be utilized and how you can capture it. So for this year, we're just starting 2017, so I'm going to look at 2016's data because it's complete. And so you're doing a prediction, you're doing an estimate. 2016 may be the norm, it may be outside of the norm, but let's take a look here. So how I'm going to do that is I'm going to go to 2016 in the standard report, and I'm going to go to monthly data. Now what you find for Payson is January of 2016, and then you have all the data. This is a lot of information, and so I want to show you just a little bit of this because for people in the any agricultural field, this is interesting information. So max air temperature, minimum air temperature, average air temperature, you have the dew point, you have the relative humidity, min, max, and average, you have the soil temperatures at 4 inches and at 20 inches, you have the wind speed, solar radiation, rainfall events on each day, and then you have some evapotranspiration and heating degree units. There's a lot of information there that you can pull from. And so if you were to go through January and look for precipitation events, I see some here in 2016. It tabulates here for the average total at the bottom, so 4.11 inches for January. I can go through each month and calculate those up and add them, but since we will also be talking about evapotranspiration in this class, I wanted to show you that a good reason for AZMET is it already calculates the evapotranspiration, and through that that total amount of water that exits the plant both through the leaves and exits the surface of the ground and the soil, those are total numbers that are calculated here for each day based on factors such as humidity, precipitation, cloud cover, temperature, etc. And so you'll see these evapotranspiration numbers expressed in inches. You will also see precipitation events expressed in inches. So on this January 6th, 1.23 inches of rain fell at the Payson location. All right? And so the benefit to this is instead of tabulating, the precipitation accumulates. And so as we get down to the end of January, you start to see that same number that we saw on the previous page. So as we work our day down through the year, we're doing 365 days in a year. So I'll just scroll my way down to the end, and you'll notice March, April, May, very dry, typical of Arizona, and then all of a sudden something's going to happen. We're going to hit the monsoon in July. and you go from what was close to 5 inches to 6 to 7. We start accumulating very fast here in August. The dryness creeps in again in the fall, and then again in December we get some high precipitation events here to end the year. And our total rainfall at this location was 22.22 inches for Payson, Arizona. Now Payson has a lot of this winter time is in snow precipitation, and so that would be the melted equivalent of that snow melt. So now we have this number, 22.22 inches for the whole year in Payson. So now what I'm going to do is I'm going to open up the rainwater harvesting calculator that I've provided for you. Once I open that up, you will see some irritating advertisements, but the information here for doing this calculation, this explains to you how it's calculated, but let's just go through the data. So in the example I'm giving you, a building in our discussion question where you're answering this question, I'm telling you that the building is 1,500 square feet. So let's just go crazy and say it's 100 feet long by 15. I know this is a long, skinny building, but just bear with me. 100 by 15. If I calculated that, it would give us 1,500 square feet of total living space. So now here's what we're looking at. This is where you put the rain depth. We are expressing this in inches, which we could convert it to feet, but let's put in the 22.22 inches that we showed for Payson, Arizona. This number here, the estimated water recovery, is just putting on a fraction of water that would be purged off, that would be wastewater, maybe your roof line, maybe your barn, maybe your metal building, whatever is calculating the water. Some of that water needs to be purged off because soot, debris, grit gets up there, and so you would waste a little bit of it. And also, if there's a wind event associated with the rainfall, evaporation that might be occurring associated with rainfall, 60% is a conservative amount of rainwater to hope to collect. So we have our 1,500 square feet, we got 22 inches for the year, and we calculate. If we were to collect for the whole year off of a 1,500 square foot building in Payson, Arizona, the total volume of gallons that we would collect after factoring 60% would be 12,466 gallons. And so I want to caution you, we could collect 12,466 gallons for an entire year. So to do that, you would need at least a 12,000 gallon tank. But keep in mind that we can look at the frequency and the duration of those events, and then we can also compare our plant's needs. And so you would never collect 12,000 gallons. You could look through Payson's data to see what the highest one-day rainfall total was, and maybe it's an inch or 2 inches, and you could size your tank to collect, for instance, 2 inches of rainfall in a major event. You could calculate that here, and that would be the most that you could collect at 60% efficiency on a 1,500 square foot building would be just over 1,000 gallons of water. And so this is a good tool for determining how much you can collect. The next connection to that would be to say, how much could I grow with that much water, and what's the duration between events like this? That's why going back and forth between the AZMET available data here, you can get lots of information to help size your rainfall watering system. All right, thank you.